Good morning, Professor Thongchai and friends of mine. Look at these pictures. Waste incinerations, co-burning, the effluents from the textile industries, or even mining. These are the examples of the industry that causing the high environmental impact. Besides, these industries release some effluents, which also can causing the environmental impact. Once if the effluent doesn't passing through the improper treatment, imagine what will happen. What will happen to the living organism there, or even worse than that, to human health. And in some case, these effluents contain heavy metals. And these heavy metals, for example, iron, lead, zinc, or cadmium, and so on. These metals is very toxic to humans. Look at the workers' hands. Their hands are swelling. This is because we call the skin lesions caused by the arsenic poisonings. And what about on the black and white pictures? Their hands look abnormally. This is the effect because of the mercury poisoning. So you will see that these are just the only sample, and it is very damaging to the human health. So I think treating effluent before releasing to the environment is the best choice here. Normally, ion exchange, reverse osmosis, or membrane separations, and etc. are the example for the conventional wastewater treatment. However, adsorption is also an interesting choice. Here, my presentation will be focusing on one of the techniques of the adsorption, which are called MSPE, or magnetic solid phase extraction. And this picture shows how it works. Basically, we add the magnetic particle in the sample, water sample that contain analyte, and then this magnetic particle will interact or absorb the analyte in the water sample, and then we apply the external magnetic field in order to separate magnetic particle with analyte with the water sample. And then one of the good things of this technique is that we can reuse or regenerate magnetic particles by the technique elutions and separations. And MSPC, as I mentioned in the previous slide, that they use the adsorbents. And here I will focus on the magnetic nanoparticles. Why is it good and interesting? Because it has a simpler and faster operation with better recovery, as I mentioned in the previous slide, low cost of maintenance and operations, reduced organic solvent consumption, and lastly, easily combined with other methods. And now I will show you the basic structures of the magnetic nanoparticle, which we call core shell structures. And you can see that the core part gives the magnetic properties, and then the core part will cover with shell part, which is to help reduce the aggregation between particles and enhance adsorption capacities. And for additionally, we can add the functional group modified on the shell surface in order to increase the adsorption capacity with high selectivity to the specific analyte, or in this case is the heavy metal ions. And when we talk about the shells of the core shell structures, it can be both inorganic and organic. But here, I think organic coating is more interesting and now gaining more popular, because organic is safer and easy to eliminate after treatment. And also very limited research has been researched on this, so I think it is very interesting to research more about this. And here I choose the cellulose magnetic nanoparticle. Why is that? Why we use cellulose? I think cellulose is the constituent in all plant parts. So it is a renewable and the most abundant natural resources that we can make use of it instead of being discarded after we use it. The corn cob, spent grains, or sugarcane bagasse, as you can see in these pictures, these are all the plant waste that we need to eliminate. But it is better to recycle them. And the other advantages is that it is cheap when compared to other techniques with a high modification potential, with higher absorption capacities, and also lastly it has super paramagnetic properties. But you may wonder that what is the super paramagnetic properties? I will explain to you. Is that once the magnetic nanoparticle is magnetized by external magnetic fields, this particle will act like a magnetic, small permanent magnetic, and this magnetic will will absorb the heavy metal. And once we remove the external magnetic fields, this magnetic nanoparticle exhibit no magnetic properties. And I personally am interested to use this topic because I think it is lead toward to more sustainability. And this research paper, which I use as a main reference, the paper called Preparation and Characterizations of Nanomagnetic Cellulose with Fast Kinetic Properties Toward the Absorption of some metal ions. And their objectives are to study the characteristics of nanomagnetic cellulose, functionalize with amino group, and then they study the absorption capacity with the regeneration possibilities of these absorbents. So let's see what is the materials and method they use here. For the chemicals, these are the four main chemicals that used in this research paper or are purchased from the Sigma Aldrich. And for the method, we are mainly separated into two parts. First one is the preparation of absorbent, and the second one is the application of these prepared absorbents. For the preparation of absorbent, first we dissolve the cellulose, and then we prepare magnetic cellulose, and then we grafting them. Lastly, we immobilize this magnetic cellulose grafting. For the application method, we use the obtained immobilized MCTs or magnetic nanoparticles, and we study four main contents, which are characterizations, absorption studies, regeneration experiments, and real wastewater sample treatment. And these are the results and discussions. For the characterizations, we use three equipment, which are TTA, TEM, and XRD, actually to confirm the success of cellulose modification. So let's see the curve for the TTAs. As you can see that we can, this TG curve show the cellulose curve and MCTTs. And you can see that these two exhibit different thermal behaviors. And you can see that MCTT or in the temperature range of 19 degrees Celsius, you can see that both curves have the cellulose base loss. But for the MCTT or the curve D has after that has the gradual weight loss until up to 203 degrees Celsius. But on the other hand, you can see that the cellulose curve or curve A exhibit different behavior by they have the thermal stability first up to 222 degrees Celsius and then suddenly drop, as you can see in this curve. So totally we can summarize that the cellulose has higher thermal stability than the MCTT. The next one is the result from the TEMs. And these three figures represent the different pictures of the MCTT, magnetic iron oxide, and heated MCTT. Actually, we conduct the TEM to see and confirm the size of the MCTT that it is in nanoscales. So when we look at the figure C, even it is heat up to 900 degrees Celsius, you can observe the particle size is in the nanoscale range. And for the X-ray diffractions or XRDs, when we look at the XRD pattern here, we can see that MCTT structure exhibits low crystallinities and show effective role of dissolved cellulose on crystal post of magnetic iron oxide. And the second study is the absorption studies. This curve represents the effect of pH on the uptake of these three heavy metal ions. And you can observe that for the curve of copper and silver, they exhibit the similar trend which are increasing uptake as the pH increases. This is maybe because of the mechanism of complex formation between nitrogen lone pair of electron and heavy metal. On the contrary, you can see that the mercury curve exhibit different trend from the two curves that I mentioned before. So you can observe that at pH 2, the main mechanism are predominantly by the anion exchange, and after pH 2, this will the predominant mechanism is governed by the complex formation mechanism. And for the effect of time on the uptake of these three metal ions, these three curves exhibit similar trends, and you can observe that this absorption process has very fast kinetic, and its maximum uptake can be achieved within 3 to 5 minutes. So we can say that this process has very fast kinetic comparable to the cellulose-free adsorbent with other different functionalization. And moreover, the octane data fit with the Lagrange equations, and the maximum uptake of these three metal ions are recorded in this table. Moreover, we can conclude that as the temperature increases, the absorption capacity decreases. The isotherms are also used to evaluate the chemical and physical properties, and it can be concluded that this absorption process follows chemical absorption mechanism. And for the thermodynamic parameters, it shows that this absorption process is spontaneous. And the third study is the regeneration experiment. And the results show that this adsorbent has higher absorption efficiency up to 99% with around 8 cycles for regeneration. And the last study is the real wastewater sample treatment. The researcher collect the real industrial wastewater which contain many heavy metals. And then they add the adsorbent and see the efficiency of the adsorbent. And the results show that ranging from 65 to 100% can be removable. So to conclude, this nanomagnetic cellulose can exhibit effective absorption capacity and also has a fast kinetic within 3 to 5 minutes. And then the good regeneration possibilities. And lastly, with application to the real world industrial wastewater, it is practical and can be promising technology in the future. And after I reading this research paper, I am interested and I want to develop further research on this. But I will do modification cellulose with a different functional group, which here we call quaternized cellulose. And then this cellulose will be synthesized from the cassava pulp. Why is cassava pulp? I think in Thailand has a higher amount of generation of the cassava pulp. So I think it is better to reuse this cassava pulp instead of this kind. And also I will study the coating and study its characterizations. And also lastly, I will study absorption capacity for heavy metals. For example, cadmium, chromium, and lead. And these are the references I use for my presentation today. And thank you for your attention.
ลายกล้องเริ่มด่วนเที่ยวกล้องเริ่มด่วนกล้องยังไม่เสร็จนะคุณดูดิ
ให้มันเห็นคำว่าแต่งที่อยู่แล้วนะโอ้ยนะมันแตกต่างกันตกมาแล้วนะนี่ดูเด็กชื่อเห็นหน้าผมอ่ะหน้าดำไหมให้ผมคุกเข่าให้เร็วยังไม่ได้ถามเอาสิเดี๋ยวถามก่อน